Here's another problem where we're using a calculator. We have this diagram with some triangles involved, some sides labeled, and we're trying to find the length x from here to here. Now there are several triangles in this picture. There's a right angle in this corner. Some of you may be tempted to use this triangle that I'm outlining right now. But you know, that's not a right triangle, so we don't want to try to apply SOHCAHTOA to that triangle that has x as a side. I think really the key to this problem is finding right triangles we can work with and maybe finding some other values before we find x. For instance, we can possibly find that length, and we can possibly find that length. I'm going to call this one A, this one B. If we can find A and B separately, then we can just subtract A minus B to get the result we want. So let's draw some pictures here. Let's just draw that piece of the picture where B is along here. We have a right angle. We got 300 there. We got 42 degrees here. And then I'm going to draw the triangle I get by going around the outside of this entire figure. So it's a larger triangle where this base side is the side A. I have the right angle here, I still have the 300 side, and I have an 18-degree angle here. And see, these are both right triangles. Neither one involves a side x, but I think I can figure out a value for A and for B, and then it's not a big deal to just subtract those two values to get the x we need. Here, let's see, I got 42 degrees, I got opposite and adjacent, so I think I can say tangent of 42 degrees is 300 over B. And in my other triangle, tangent of 18 degrees is 300 over A. Now, I could go right ahead and plug in values for tangent 42 degrees, tangent 18 degrees, and of course you should do that if that seems easiest. But if you want, you can also try to work with these expressions for tangent. And some people like to go as far as they can in a problem with the expression tangent 42 degrees, tangent 18 degrees. That's really up to you as far as I'm concerned. At any point you can replace these tangents with decimals. So for instance, if I tried to work with them here, I'd take that first equation and multiply both sides by b. B tangent 42 degrees equals b times 300 over b. I have to do that first because b is in the denominator. B tangent 42 degrees is 300. And now I can divide both sides by tangent 42 degrees to get b isolated. B is equal to 300 over tangent 42 degrees. And really it's the exact same kind of calculation here. And the other, a tangent 18 degrees, is going to equal a times 300 over a. The a's cancel on the right. And now I can divide both sides by tangent 18 degrees. And I get a is equal to 300 over tangent of 18 degrees. My tangent of 42 degrees is about 0.9004 when I round off. tangent of 18 degrees is about 0.3249, so make sure you're in the correct mode on your calculator, so you're getting values. Those values are something very, 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 very close. And then when I plug in and divide, I get that B is now about, because I've rounded off a bit, 333.2, and A is about 923.3. If you work with the exact or the more precise values of the tangents, you may get a more accurate answer even than mine. There's no absolute right answer here. We should all just be very, very close. So as long as you're reasonably close, I'm not going to zing you for having rounded off. It can be tricky business, because if you round off at a slightly different point in a problem, sometimes your answer will look slightly different. So what do we want? We want x, right, is equal to a minus b, which is 923.3 minus 333.2. So x is about 590.1. That's our x value for this problem.